Hi everyone, my name is Cody Khuu and this is CS14 SI. I will be your SI for today's video. For today's video, we'll be going over templates, stacks, and queues. For stacks, it's a fairly simple concept where we can place information in a LIFO type of list, which means last in or first out, meaning that we can put information in the end of the list and we can also remove the information from the end or the top of the list right here. So we see we push this item up on the top and we also pop this item from the top again. We can also create a pointer or variable that specifies the current item on the top of the stack and keep track of it as we either insert or pop the stack. No special syntax is required besides tracking where the top of the stack is located at. It all just depends on how we move and manipulate the code. Alright, well, let's look over at the code. Alright, before going into stacks, let's see how we create templates. We have a class called an array right here. And above that line of code, we have template type name t. This indicates that this class is a template class, meaning that we now have to follow the rules of templates. Additionally, we have access to create t variables right here. These variables can be any type depending on what we set them from the main function or from any other function inside this class. And for every function or constructor we make for the template class, we have to add the template type name t right here again before every name of the function. And instead of just the name of the class, we also have to put the caret with the template variable inside when creating each function. And calling these constructors are going to be a little different. First, let's get down here first. First of all, the name of the class has to be right here first. Then inside, we have caret brackets with the type we want. The name of the variable equals to the name of the class with caret brackets again. For this constructor, we are adding a size to this right here. For template t values inside of functions, in case where we are copying the array and doubling the size, in the function resize, we do not know what type the array we are copying, since this array can be char, int, or string. We can just label this as type t, and it will change its type to whatever type we had inserted inside the main function. Okay, so let's now talk about stacks. Alright, so we have a type t right here, pointer. This basically holds the array. We have size and the capacity of the array. We also have a constructor that allows us to make an array with a size in there also. We can also print the array right here, showing its capacity and size. Going down, we can also add variables inside the array. It has a type t in the parameter since we can add any type of variable into the array. A resize function is right here also when we need to double the array capacity. Going down a little bit more. We also have a pop function that basically just removes it, which basically removes an item from the top of the stack. And lastly, we can get the top of the stack and pop it at the same time using getPop. And so let's compile this and run it. Okay, after compiling, we see that we created an array right here. We added 4 and 5. In this case, we consider the most recent integer, 5 right here, to be the top of the stack, so that the right side of this array is basically the top of the stack. Then we add 10, but the capacity is equal to the size, see they're both 2 and 2. We now have to copy it into a new array and double the size. See right here, 4, 5, 10, capacity 4, size 3. And then, after that, we remove 10 by popping it out of the stack. So this is 4 and 5. And then we also do getPop, which basically just returns 5 and 4. We do it twice. So now that the capacity is still 4, and we have nothing inside the array. And at the end of it, we add 8 and 24, showing that it still has its capacity and the size still works. And so pretty much the takeaway from this is just looking at how stacks could be either used from arrays or a linked list, and just making sure that when we add things, it's put on the top of the stack, in this case the right-hand side. And when we pop them out, it's also still on the right-hand side, so we only take out, like for instance right here, 10, and then 4 and 5 right here, respectively. For queues, it's a little bit of a different story. It is FIFO, which is first in, first out. If you think of people waiting in line, FIFO is the first person in line, is the first person to get removed from the line. A person getting into the line is pretty much in queuing, so getting in the back, while a person being removed from the front of the line is dequeuing. We could use arrays or linked lists for making a queue, but we mostly want to use linked list due to the better runtime. Since if we dequeue an array, we would have to shift all of the people in the line by 1 to the front of the line, which takes around O of n runtime, while dequeuing and nqueuing in linked list only takes O of 1. Their code is a little bit similar to each other from stacks, except that we remove from the front and add to the back. Other than that, they're pretty much the same. I hope you find this video helpful. If you still have any questions, feel free to comment below, and we'll be happy to answer your questions. Thank you very much, and I'll see you guys next time.